Thanks a lot, Christine, and good afternoon, everybody. Really happy to see you all here. So, as Christine said, I'm chief scientist at FAIRTIQ, but what's really important here is that before even we launch this product on the market, I helped to really design and shape this product to see whether it was possible at all to build this product before we brought it into the market. And that's what I'm going to share with you today, the key insights to building, the products that work with location data from the mobile devices, and how to, what are the trade-offs in annotating the data and in establishing some key metrics to make sure that your product, you're building something that is really good and your product is working really well. All right, so let's jump straight to the business. So I'm going to first do a short introduction to FAIRTIQ, what it is for those who don't know, and then we're going to start talking directly about location data. So we're in the transport track, right? So what is transport is about location data. We need to know where you are, and then we're going to talk about the data annotation and how we can establish the quality assurance for the product, right? So what is FAIRTIQ? So the FAIRTIQ is the app to buy public transport tickets, right? So, but it's different from your typical public transport app, different from what you find on SBB or in the ticket machines where you need to specify the origins and destinations from where you're going. With FAIRTIQ, you simply register with the app and then you check in within the application, and then you immediately get the ticket, which is valid. So far it works in the whole of Switzerland. So for example, if we're talking about Switzerland, it will be valid across the whole Switzerland. You can travel non-stop in the whole of Switzerland, and after you finish your travel, you check out and you get the best price for the whole of your journey. So if you do more trips also with FAIRTIQ during the day, we take into account the trips that happened in the past that you did, and then we compute, we would compute the best price given that we would know, like as if you would know what you have done in the past. So you don't need to take care of this. So that's what it is about, and the way we're doing this is that the app periodically sends the location data from your device to our service so that we can reconstruct the trip that you did. Alright, so how is the data actually collected from the app in more detail, and what do we care about? We care about, so location data is essentially these 4 key attributes that we have. So first one is time. Obviously every location is timestamp, and then you have the latitude and longitude to identify your position on Earth, right? And then the 4th parameter, which is maybe less well known, is accuracy. So the accuracy is something that is provided by the mobile device that says basically what is the probability, like the high probability that you are within this radius of location. It can vary depending on the methods of data collection that we're using. And if we go into the methods what we're using, so to describe how it's used, so every mobile operating system, whether it's Android or iOS, doesn't matter, they provide different modes to collect the data. So of course you can rely only the GPS data, and this will be very precise along the track, no matter what, unless, outside, of course, you need to take, buildings and, trains, metal environments into account, but basically it's very precise. However, it comes with a huge cost of the battery usage, and this is something that we cannot afford in our app. Otherwise, nobody would use it if it drains your battery in 1 hour, right? So what we're going to talk about is another mode. It's, for example, on Android it's called priority balanced power accuracy, and the way it works is that it fuses the data from multiple sensors into one, and it provides you the best possible location based on this sensor. But the key thing here to understand is that you don't know what sensor was used. You don't know whether it was Wi-Fi, whether it was the cell towers, or whether it was GPS at all. So you just have the location, and that's it, and you have to work with this. So that's something that is present in both Android and OS, and that's what we are using, and that's what we're going to talk about, what challenges does it pose. So the first challenge I'm going to talk about, or like the aspect of the geolocation data, is that it's unique, right? And what I mean by unique is that even if you do the same trips, right? For example, from Bern to Zurich, if you do exactly, if you put two devices, exactly the same device, exactly the same models, you start at the same time with, with the same application, you get a different data, right? So you get more or less the same data, but it will be always a bit different in latitude and longitude. So you cannot just, write, if you're thinking about, writing an application, you cannot just hard code what is the data there that, between Bern and Zurich you always get this data. No, it will always be a bit different, and that's something you need to take into account while building in, the apps that work with the data. So the system needs to be robust enough to take this into account. And to illustrate this point even more, here is the aggregation of 1,000 trips between Bern and Zurich. You can see the distribution is more or less along the train line of Bern and Zurich, and with a slight detour. Sometimes trains are get stuck in the tunnel, so another train have to have a delay. But in general, you see that there are more than millions of points here, and they are all slightly different, even though they are centered around the track. So you need to take care, and the system needs to be robust to take care of this. And the second thing I'm going to talk about, it's a bit fast here, but it will restart again, is the so-called outliers. So an example here is the trip. Again, now it's from Zurich to Bern. You can see the development of the trip is in kind of real time, in the accelerated time. And what you see here is that even though you get the locations first along the line, but then it can start jumping, right, to Basel, for example, in this case. And this can happen, any time during the trip. And again, so you don't know why it happens. That's the way the system returns, the mobile phone returns data to you. But that's something, again, that's yet another point that you need to take care about. And the system needs to be robust enough to handle those so-called outliers, right, from the data that, that jump to completely wrong, and your system needs to be smart enough to remove them, or, take them into account so that, we don't calculate the ticket from you to Basel and then back to Bern. That's something very important. And then another point is the precision of the data. So as you notice, the data, we talked about, this accuracy of the data. And again, if we analyze the trips done by different modes of transport, done in the train, in the bus, and you're walking, and we build this distribution of the accuracy, you can see that, in the train, the data is typically much less accurate. So this is the probability density distribution of the accuracy. And you can see the blue line in the train, the probability that you have a very high accuracy is much lower for the train than you can see in the bus, and, for walk you get even higher accuracy. So that's something, again, yet another aspect that you can think in your system to see that, I'm walking, then I probably can say that my data, my accuracy will be higher than I'm in the train. And you can use it basically in other aspects, for example, in your machine learning system to understand what are you doing right now, whether you're walking or whether you're in the train, for example. And then the last aspect is the integrity of the location data. So we're collecting data from the system, and you typically, again, on the mobile phone, you specify the interval of which you want to collect the data. So for example, you said I want a location every 1 minute, or I want a location every 30 seconds, right? And even if you do that, the operating system still cannot guarantee you that you will get, location exactly every 1 minute or exactly 30 seconds. And here to illustrate this, we collected again the graph from 1,000 trips of the distribution of the gap in time between two consecutive locations that we got from the system. And you can see here that, even if you say it's 1 minute, there are still, so it's a logarithmic scale, but you can see that there are still cases when you get 1 hour difference. And I just cut it into 1 hour. It can be even longer. So the system, for various reasons, might not be able to deliver you this location. Either it can be, the throttling of your application, or maybe, for whatever reason, it might not be able to deliver it. That's something, again, that the app, if you build in the app that working with, with this location data from mobile devices, that's something that you need to be aware of and take into account, and, yeah, so that the trip in the end or your data get interpreted correctly, and you don't, charge or, affect the user in any way with this. So to summarize what we talked about the data challenges, so first is unique, data is never the same on the same path, and it's never the same in different vehicles. And there are also outliers because we use fused location sensors, so not only GPS. The data is fused, and you don't know where it's coming from, so outliers are possible. And then that you might have a time lapse in collecting your data. So either because, so that's what we think, either because you're underground or you have the operating system throttling so that it simply puts your app into sleep, and doesn't want to collect the data the way it wants to be. Alright, so now that you started to collect some data, you start building your system, and what are you going to do next? Right, so then if you want to see like how your data is performing, you first need to start annotating the data. So you need to so-called ground truths. And it might depend on the application, right? Your ground truths that you want to annotate your data with might depend on the application that you're building, your prototype. So I'm going to talk about here about the FAIRTIQ case and the public transport case specifically. So here is example from Google that you might see if you have an Android and you're using Google Maps. You might see that it gets you that such a reviews every time that you can say, for example, you're interested in modes, and what are we annotating here is really the data. So the location data from one place to another, and then you want to say something about this data that your system learns from it. So for example, you want to say, I was in the train, or I was in the bus, or I was driving. And that's essentially the ground truth, that you want to annotate this data, and then to predict these annotations yourself when you were done them. Right? And in our case, there are also multiple possibilities. So we want to, from this location data that we collected, we want to output the public transport trips. And the possibilities basically are endless to annotate this data. So we have names of the stations, we have the types of the train, we have the specific numbers of the train, and we have the departure and arrival times and platforms. A lot of possibilities to annotate data here. But what I'm going to talk about is the trade-offs. So, for example, in our case, we decided to annotate only the stations. And why we decided to do only that? Because we thought, we can get a lot of extra annotations for free. Because we already have the location data, right? And if we decide to annotate just the stations, and then we combine it with timetable data, for example, we can get all these types of the vehicles and the times for free, just combined with location data. So imagine here, what is important to understand are the trade-offs. You can spend a lot of manual effort doing all these, detailed annotations, while at the same time you can annotate, 10 times more trips with just the stations, with just, the simple interface to annotate, and you basically, in the end, you get the same data than the person who decided to, do a very detailed annotation, but annotated just 10 trips with them. So that's something, again, yet another trade-off to take into account when you're developing, annotations for your data. All right, so the annotations we have, the location data we have. What's next? We started building our algorithm, and we want finally to know whether our system is any good. And for this, we need a concept. Called metrics, right? So we want to develop a metrics that will tell us that whether we can release our system to production. For example, now that we have the matching for the location data and our annotations, and now we want to get new data and basically design the metrics that will be good for us and see what our system scores on this metric. So in our use case, when we're talking about the trips in the public transport, so for example, here is a trip, the ground truth, and the system output, we can design a metric based on precision and recall. And precision and recall, like in this case, we can implement it in a very simple way. We can say, if all the stations are the same, then precision 1 and recall is 1. And let's see what happens if one station is missing, for example, then your recall drops. And if, on the other hand, you add extra station, then your precision drops. So this is useful, and that can give you the insight of what your system is doing. But this also has certain drawbacks, right? And the problem with the precision, the way I define it there, is that it treats its element as unordered sets. So, for example, if we go from A to C to B, and then to D, the precision and recall will stay the same, because we didn't take into account the connections between the elements at all. And even worse, like if you go again back to C, you have precision and recall still 1, the way I define it. And this is something bad, because we don't want people to come back again to this, as it's, we will probably issue a wrong ticket if we do this. So one better way to do this is to do a sequence alignment. When we really care about the order of the elements, and we can see that we count the changes in the order as elements, as the sequence alignment in the text, for example. We can count them as insertions and deletions, and we can identify precision and recall in the way that takes these insertions and deletions into account, and then it decreases them, because you had non-empty insertions and deletions. And that's so the key point here in the metrics is that you need to be very careful in designing your metrics in advance, because if you design a wrong metric, it can show you that your system is very good, but actually in certain specific cases it doesn't perform well, and you're just not aware of this at all. And you release this system, and the users start get wrong price, and you don't understand why, because you don't have this insight at all. All right, so the key takeaways to say here is that be aware of the challenges of the working with location data if you're starting, building this system that operates with the data collected on the mobile phone, and then know what to annotate and what to automate. So think about automated, how you can reduce the manual effort to annotate, so how you can annotate as less as possible and automate as much as possible with having the same result. And then, of course, know what to measure, so that that you can be sure of your system, that it performs right and does what you intended to do. So thanks a lot for your attention. It was my pleasure to be here, and if you have further questions, if we run out of time, feel free to connect with me on LinkedIn and have this discussion further. Thank you.